Hi there! Today we're going to discuss about factoring of algebraic expression. There are so many types of factoring of algebraic expression. These are quadratic trinomials, perfect trinomial square, difference of two squares, sum and difference of two cubes, common monomial, and factoring by grouping. Now each of them will be discussed clearly to you. We're going to discuss each of these today, and we will start with quadratic trinomial. The first factoring is what we call quadratic trinomials. Here's the first example. Okay, we have an expression like x squared plus 5x plus 6. Alright, the first thing that you have to remember is to look at the sign of the last term. This is the first term, the second term, and the last term. Remember, concentrate on the sign of the last term. Of course, there are only two signs in algebra. One is positive and the other one is negative. So for this example, we have positive. So how are we going to answer that? First, you have to write two parentheses. Okay. Now remember, if this last term is positive, all you have to do is to copy the sign of the second term for both parentheses. So since this is positive, both of them should be positive. Okay? That's the first thing that you have to remember. Second, the square root or the factor of x squared is nothing but x here and another x here. That makes it x times x will give you x squared. Your only problem will be the last term here. Okay, in order to determine the answer for both terms here, all you have to do is to find the factor of 6, meaning you have to think of two numbers when multiplied together will give you a number 6 or the product 6, and that is 3 and 2. That means 3 times 2 will give you 6. But not only that, because you know, another factor of 6 could be 6 times 1. That's also 6. But here, we're not going to use this simply because the product of 3 times 2 will give you 6. And also, the important thing here is that this plus sign here would mean you need to add these two factors and it should give a sum equal to the coefficient of the middle term. So the coefficient of the middle term here is 5. So it should be 3 plus 2 will give you 5. Therefore, this is the correct factor and not this one. Because this could be 6 times 1 is 6. But the sum of these two numbers is 7 and it is not equal to this number. Okay? So we choose 3 and 2. The good thing about this is that these two numbers can be written here interchangeably. Meaning you can write it the 3 here or the 2 here, or you can write it the other way around. Okay? So that's the first example. Okay. Maybe I can erase this now. Alright, let's have another example. Okay, what if we change the variable, let's say y squared this time, okay, minus, let's say 11y, and then again plus 30. Okay, you will notice that the last term are both positive, but I changed the sign of the middle term. First it's positive, now it's negative. What will be the effect in terms of the answer? So once again, we write two parentheses here. Okay. Again, since this is positive, you just have to copy this negative sign here for both parentheses. And again, the factor of y squared is nothing but y here and another y here. So y times y will give you y squared. Okay? Again, we need to think of the last term here. And we can do that by simply finding the appropriate factor of 30. And there are so many factors or pairs of numbers that when you multiply them, it will give a product of 30. Okay? So let's try 2 and 15. 2 times 15 will give you 30. That's correct. But when you add these two numbers, because this is addition or positive, when you add this will not give a sum equal to this number, 11. Okay? So 2 and 15, though they are factors of 30, is not the appropriate factor for this problem. Okay, let's try 6 times 5. Again, 6 times 5 will give you a product equal to 30. But then again, when we add these two numbers, 6 plus 5 will now give you 11. And that is exactly the coefficient of the middle term. Meaning to say, this is the most appropriate factor of 30 that will give a sum of 11, and that makes the answer correct. Again, these 6 and 5 can be written wherever you want to put them. So you can put the 5 here and the 6 here, or the other way around. Okay? So that's about the quadratic trinomial if the last term is positive. Now, what if the last term is negative? As I said a while ago, there could only be two signs here. One is positive, the other one is negative. So let's try the negative. Okay, for example number 3, we have expression like x squared minus 2x here, and this time we're going to make the last term negative. Okay, let's say this is negative 15. Okay, again we put two parentheses here. Okay, notice what will be the changes as we compare it if the last term is positive. Remember this, when the last term is negative, all you have to do is to write two different signs for the parentheses. So it could be one positive here or one negative here, or it could be you write the negative here and the other one is positive. Okay? But just the same, the factor of x squared will be both x here. So x times x will give you x squared. And again, just the same as this one, we need to find the factor of 15. Okay? It so happened that the factors of 15 could either be 15 times 1 or 3 times 5. So let's try 5 times 3 or 3 times 5. Okay? So 5 times 3 will give you a product surely equal to 15. Now here's the key. This time, we are going to subtract these two factors here because the sign is negative. Okay? As we subtract this, 5 minus 3, it will give you a difference equal to 2. And that is exactly the value of your coefficient of the middle term. So, these two numbers will be the appropriate factors of 15. However, we need to understand that there are two different signs here. Unlike here, we have the same sign. So, you can write the factors interchangeably. Meaning, you can change the position of these 5 and 6 and 3 and 2. Here, you cannot do that. Okay? So, how do we do that? You choose the bigger number. In this case, the bigger number is 5. And you write 5 where? Is it in positive or negative? You write the bigger number, the bigger factor, okay, to the sign similar to that of the middle term. So, since our middle term is negative, you have to write the bigger number, which is 5, also in the negative side. And the number 3 here, or the factor 3 here, should be written in the positive side. You cannot interchange the position of these two factors because they will all depend on the sign of the middle term. Okay? So this is how we get the factors of trinomial. Let's have another or final example. Let's say we have y squared, alright, minus y minus 12. Okay, what could be the factored form of this expression? Again, we put two parentheses here. Alright. Now, you look at the sign of the last term. Since this is negative, one positive here and the other one is negative. Because we have the first term as y squared, the factor of this is nothing but 1y here and another y here. Okay, that will give you y times y and y squared. Now, again, we find the factor of 12. Okay, this time, the difference of these two factors should be equal to 1. But where did I get the number 1? As you can see, the middle term, the only term here is negative y. This negative y has a hidden numerical coefficient equal to 1. It's just like this is negative 1y. But we don't write the 1 anymore. In other words, the coefficient here will always be 1 if there's no number indicated in the coefficient. Alright? So, the factor of this 12 could be 6 times 2, 4 times 3, okay? But we choose the number whose difference is equal to 1. We find 3 here times 4 will give us a product of 12. And at the same time, when you subtract 4 by 3, it will give you a difference equal to 1. Therefore, again, just like what we did here, we choose the bigger number, which is 4, and write it, because there are two different signs here, we write it to the sign similar to that of the middle term. So in this case, we have negative, you write the bigger number, which is 4, here. Okay? And the other factor here. Okay? So this is how we find the factored form of quadratic trinomial. Alright, so the next topic will be perfect trinomial square.